What is Brainbow? A brainbow is the colorful image that results when a combination of fluorescent proteins modify the neurons in the brain. The different protein colors combine in random ways, thereby creating approximately 90 individual hues and giving a distinct appearance to separate neuron pathways. Some of the stunning images that result have won scientific photography awards. This technique was first developed by researchers using the brains of mice, and it shows promise for the research of the many neurological disorders. The numerous colors of the Brainbow technique should allow researchers to trace and map the brain's many neuron pathways, or circuits, and should also help them pinpoint differences between the neuron pathways of healthy brains versus those affected by disorders. The Brainbow image is created by using combinations of fluorescent proteins to label the neurons in the brain so that they stand out when viewed with imaging equipment. Usually 3 to 4 colors of fluorescent protein are activated in the neurons, and these combine to produce multiple distinct hues totaling approximately 90. Each unique shade comes from the combination of varying percentages of the fluorescent protein colors, similar to the way a television creates a range of colors. The fluorescent protein colors are usually green, yellow, red, and orange or cyan. The shades expressed by the neurons are decided by random selection. Neuroscientists from Harvard University developed the Brainbow technique, which represents a significant advance in neuron labeling. They first used the method on the brains of mice, with articles and photographs published in several scientific periodicals. The images that result when the Brainbow technique is used are very colorful and vivid. They have been described as stunning and comparable to modern art or abstract painting. Photographs of the images have also received photography awards. Studying mouse brains labeled with the Brainbow method, researchers have found that the color labels last for a long time. They have been able to map neuron pathways, and trace changes and reorganization among the circuits in the brain. The variety of colors labeling the individual neuron pathways are extremely valuable to help researchers begin to make sense of what used to have the appearance of a tangled mess. Researchers are very hopeful about the potential of Brainbow labeling to learn more about a variety of neurological disorders including Alzheimer's and Parkinson's diseases. They hope that they can use it to create a map, or wiring diagram, of the neuron pathways. Once this is accomplished, they should be able to identify where and how the brain's wiring is altered by these diseases. This knowledge may lead to greater understanding and advances in the treatment of these neurological disorders.